What is C++? Well, it's general purpose, meaning it can do just about everything. There's C++ running in your smartphone, on your computer, your VCR, your TV, and the space shuttle and satellites, and pretty much every electronic device you can think of. It's a programming language, which means it's a set of instructions, and I'm vastly oversimplifying that. Now, a set of instructions means you are telling the computer what to do and how to do it. The problem is computers are very fast but very stupid, meaning they will do exactly what you tell them to do. And C++ gets you very close to bare metal, meaning you can do just about everything from, well, high-level multi-threaded TCP servers to making device drivers that interface with hardware. Now, C++ was created by, and I'm sorry, sir, I'm going to horribly bastardize your name, Bjarne Stroustrup. It is an extension of the C programming language. That's right. That means there's a language out there called C, and C++ builds upon that. It's actually called C with classes. So what Bjarne did is he made a bunch of extensions for C and added them in, and it became now what we know as modern C++. Again, I'm overly simplifying that, but at its core, that's what we're talking about here. Now, C++ gets a bad rap because it can be very challenging. There are people who've spent a lifetime working with it that still make mistakes. I'm one of them. But as you progress and as you get more experienced, it simply becomes easier. And then you'll get to a point where you'll look at C++ and you'll think, why is anybody else using a different language? This is so powerful. Now, if you've done any research on programming languages, you'll know there's a ton of them out there. So why even use C++? Well, it's fast. I mean, really fast. Faster than a cat at 2 in the morning running down the hallway. What makes C++ so fast is it gives you raw memory access, meaning you now can control the memory, and therefore you can do just about anything, just about anywhere. And it has stable long-term support. I can really testify to that. I've been working with C++ for a long time, and it's maintained relatively stable. It's undergone a lot of changes, but most of the code that I wrote decades ago still runs just fine. So compare that to more modern frameworks. Well, guess what? Those modern frameworks change so fast, you don't know what's going to run and what won't run, and you spend most of your day trying to figure it out, where C++ is just pretty stable. One question I'm often asked by newbies who are shopping around for the perfect programming language is, what can you make with C++? Well, anything. I've said that quite a bit. Anything. Now, anything is a wide array of, well, possibilities. So to kind of clarify, everything from microchip embedded systems to car dashboards, cell phone components, any pretty much major electronics runs C++ at its core if it has any sort of real logic system in it. It's either going to be C or C++. Almost every major video game is written in C++. Well, pretty much a lot of the components that are not just straight out electronic hardware run C++. And yes, most major software frameworks at their core are usually either C, C++, or usually a mixture of both. We're talking about things like Java, Python, .NET, those kind of things. Now, yes, you're always going to have that outlier that runs on something completely different, but at its core, most things boil down or distill down to a C++ or a C. That being said, you can create just about anything. Now, somebody out there is going to go, you can't create web pages. Actually, you can. There's an entire framework out there specifically for using C++ to create web pages. It's called a CGI. Um, the thing is, you can do just about everything, but you have to pick the right tool for the job. I personally would not use C++ for building, say, a website, although it can be done, but C++ is really good for things like video games because you need high-speed memory access. You need the raw speed of that computer. Now, the problem comes in when you try making what I call user software, or things that the user is going to work with. And that's where Qt really shines, because it takes the complexities out of C++ and puts a shiny interface on top of it. So now you can take the power of C++ and Qt and merge them together. So in the interest of full disclosure, let's talk about some challenges with C++. I've been really, kind of selling it as one of the greatest things out there, but it has a very sharp learning curve. It's very challenging. A lot of the documentation is old because C++ has been around for so long and it's slow to change. So if you're looking for the latest, greatest things, you often end up going out to Google and looking for a library that somebody else built or building the solution yourself. The big caveat here is memory management scares a lot of people because in most modern frameworks, it's just done automatically. You create something and the computer does it for you. Well, in C++, you do it. You have to do it yourself. Don't get too scared about that. We're going to talk about different ways of making it automated. However, just understand at its core, you are telling the computer what to do and how to do it. I often like this little graphic off to the right here where learn C++ in one video and then they find out it's like 35,000 hours long because there's a lot to C++. The other thing is it's not flashy. It can be very complex and it can take a lifetime to master, and even experts tend to disagree on what you can or even should do with C++. I've literally seen C++ experts get into a heated debate, and these are people who help build C++. Now, the reason why there's so many challenges with C++ is because it does have such deep integration into the computer and you can do literally anything. The problem is, just because you can do something doesn't mean you should do it, and that's where a lot of the challenges come in. Now, I don't want to scare you away with the steep learning curve. What we're going to cover in this course is a subset of C++, enough that you need to know to survive in Qt. That being said, you will not by any means be a C++ expert, and I would almost challenge anyone who says they are a C++ expert simply because the language is so diverse. All right, let's talk about the build process here. This is something that really mystifies newcomers or people who are familiar with much simpler languages like Python. So C++ has a standard build process, and this graphic really illustrates it very well. So starting at the left, we do the source code. Those are the computer instructions that we as the programmer or the developer create. We're going to hit the build button, and something called pre-processing happens, which actually is the preprocessor preparing the code to be compiled. The compilation process kicks off, and then it creates a bunch of object files. These are essentially computer instructions in computer code. This is not human readable, and if you try to open it up, it's just going to look like a bunch of gobbledygook. It will make no sense. And from there, a linker comes in and links all those object files into a nice executable or a library. All right, now, an executable would be the application. On Windows, it'd be like a .exe. And a library is, well, code reuse. You can actually create code, put it into a binary file, and give it to other developers so they can use your code to create their own executables and link to them. It gets very complex, and we're not going to spend a lot of time talking about it, but I want you to really understand there's this whole dance that happens under the hood when you hit the build button in the IDE. You're taking your code, pre-processing it, compiling it into object files, and then linking those into a binary. So let's hit the pause button for just a minute and let's talk about the C++ Qt build process. Notice this is slightly different than the standard C++ build process. So just like in normal C++, we would write some code. You'd see those H files and CPP files. Those are the actual source code files that we as a developer would write. The preprocessor is going to run on those and figure out what sort of internal changes need to be made to prepare it for the compiler. And at that time, Qt actually jumps right in the middle there. You see a little Qt logo I put in there? It's going to run the mock, or the meta object compiler. And what this does is it takes a lot of the goodness that is Qt that we haven't yet talked about and adds all of that code in the background for us so we don't have to do it. So for example, you can have two objects, sports car and stoplight, and you wanted to send a signal from one object to another saying the light's green, go ahead and go. Well, that is how Qt injects all of that functionality in there automatically using what's called a meta object compiler. We're going to talk about this a little later on, but basically what we're talking about are signals and slots along with object or meta information about objects. Qt has a lot of stuff that happens under the hood that often mystifies people, and that's why I put this slide in here. So really at a high level, we write the code, the preprocessor preprocesses, Qt runs the mock, and then the compiler actually compiles all this down into object codes, and then the linker builds the finished binary. One thing you can definitely expect is, well, issues. Problems are just a part of life. Learning takes time, and C++ can be very hard. I love this graphic on the right. You have an error on line 60 and your program is only 40 lines long. Welcome to C++. That kind of summarizes just what life in C++ is. And sometimes you have to really understand the technology just to figure out what you did wrong. So expect to make mistakes, especially because technology changes and operating systems are different. So you may get one error message on Windows and a completely different error message on Mac. This is the real world, and we're going to try and keep things very down to earth. But there are going to be times where Google's going to be your best friend, and you're going to have to figure out why it's not running on your system. I don't want you to think that you're on your own. You're definitely not. We have an entire ecosystem of developers set up using Udemy, Facebook, YouTube, and a whole bunch of other social media. But just have a little bit of patience. What you're doing is not easy, and it's going to take time. So you can expect to make mistakes, but hopefully we'll learn from those mistakes. When people think of C++, they think of it just as a language, but you have to understand in the background there's what's called the C++ standard library. And we're going to actually use parts of that in this entire series and beyond. So there's different standards. For example, there's the 98, 11, 14, 17, and 20, and that will change in the future. You notice the numbers. Those are years in which that standard was published. There's 1998, 2011, 14, 17, and 20, and you can expect more and more and more. Now, the big change is, well, in 1998, they did the STL, including containers and algorithms. That's when we get into templates, something that we're going to touch on in this series. This is when C++ really started to explode as a language and everybody started to use it. The problem is, when you have a technology like Qt and a technology like C++, they don't always align up. So sometimes you'll see me write code and somebody will say, why are you doing that in Qt when it exists in the standard library? And it may be because I just simply prefer the Qt way, or the Qt way was actually developed before it even existed in the standard library. And now Qt is going back and they're kind of pruning back parts of their libraries to realign with the standard library as it evolves. So I want you to understand that as we go through these videos, we're not just talking about Qt, we're also using C++ and parts of the standard library. And under the hood, Qt actually uses C++ in the standard library and makes it vastly easier for us to use. Now, in case you're curious as to what's really in the standard library, well, a whole lot of, well, templates, containers, they started adding multi-threading and memory access and things like that, readers and writers, lockers, things like that. And in the newer versions like C++20, you have things like coroutines and modules. Now, a lot of this stuff may just sound like, what is he even talking about? To be brutally honest, you can go your entire career without even using it, or using it and not understanding what it is in the first place. You just know that it works. Unfortunately, that's how complex C++ can get. Now, also understand that the whole intention of Qt is to make C++ easier. There's a lot of complexity with working with the standard library, and sometimes when you write code designed straight for the standard library, it's very hard to read, where Qt code is very user-friendly. So let's talk about how Qt uses C++. People often get the two confused. So for clarity, Qt uses C++, or more appropriately, Qt is built or created in C++. It also uses parts of the standard library and even replicates part of the standard library. So when you see that acronym STD, that's shorthand for the standard library. And it uses pointers. It uses a lot of pointers, which, if you don't know what that is raw memory access. We are telling the computer to go look at a chunk of memory and do something with it. It also uses classes and inheritance. Now, you may not even know what that means. Classes are essentially a blueprint. So let's say you want to build a house. You need to start from a blueprint. Once you have a blueprint, you can build many houses from that class. Now, let's say you want a house with a 2-car garage. You would take that blueprint and modify it a little bit to add a garage. That's called inheritance. So you can take an existing blueprint and modify it. All right, templates is a little bit challenging to really explain without showing an example. We're going to dive into that much later, but at its core, let's say you wanted to do something like a basic function, clean. Well, what do you want to clean? A house, a car, a hot tub? That's what a template is. And it really makes it a generic high-level version of saying, go clean this thing or go do this. Now, Qt really lacks built-in error handling. And that's one of the criticisms of it. But we're going to use the C++ error handling. And I should actually call that exception handling because there's a difference between errors and exceptions, which we'll talk about much later. But understand that an error is pretty much something that we have no control over. So, for example, the disk being full or the computer dying. Or exception is like a programmer-made problem, like a division by 0, something that we should handle. And then object copies are forbidden. What does that really mean? Well, an object is an instance of that blueprint. We're talking about classes here. So you take your blueprint, create an object. That object lives in memory. However, in C++, you can do something called a copy, which makes literally a copy or a clone of that object. Qt does not like doing that, hence we have to use pointers. All of this may sound super, super confusing, but we're going to cover the bulk of this in this course. I just wanted to let you know up front, in case you have some C++ experience, what you can really expect. Now, as we alluded to in a previous video, how much C++ are we going to really cover? Enough to learn Qt. So C++ is huge, and you can spend a lifetime learning it, and to be brutally honest, there's always a better way of doing something. So the things that I'm presenting in this class, you may actually find there is a better, more professional, more stable way of doing it. But we're showing this from a very much a beginner's perspective. So you're going to learn just enough C++ to survive in Qt. That includes things like variables. A variable is simply something that will change. We need to work with a computer, and we need to tell the computer what to do when a variable changes. For example, turn a light switch on, turn a light switch off. How do you tell what the status of the light switch is? And then pointers. So for example, where is the light bulb? It's out in memory somewhere. So we have to go find that and then work with that directly. And of course, because we're talking about pointers and variables, we are talking about memory. Memory is where our applications live. And because we are in C++, we have the responsibility of managing that memory. We're also going to talk about classes. And as I've stated, they're blueprints to objects. Qt is, well, very class intensive. It doesn't use structures that much at all, but most everything is a class, and it does use inheritance. So when you see the word class, we're talking about a blueprint. Now, inheritance is simply taking those classes, those blueprints, and modifying them. So for example, let's say you have a class called a car. Inheritance would make that class a sports car or a high-performance monster truck with big mud tires. That's basically at its core what inheritance is. It gets way more complex than that, but that's what we're talking about. Fundamentally, remember, this is a Qt course. Qt is written in C++. If you want really advanced C++ training, this is not the course. This is covering the fundamentals of Qt core.